random irregular reflection. In both cases, if lambda is the wavelength of the light that is scattered also is lambda. No change in lambda. But there is change in intensity. Change in intensity. Next step. Now look at it. This is glass, a very smooth surface. This is irregular substance like a chalk piece, board or a wall or anything. Next we go to this one. We look at molecular scattering. Suppose, even before that, before molecule, we go to particulate scattering. Particulate scattering. Which means, I send the light, here is a particle. This is a big ball. This is a particle like this particle. If the size of the particle is greater than lambda, 10 lambda, then this is called mescattering. Light gets scattered irregularly. Again, there is no change in this. Only thing is, the intensity of light scattered is proportional to omega power 4. That means, if I send light of 400 nanometer and 800 nanometer, this is short wavelength, long wavelength, high frequency, low frequency. Then this will get scattered more than this. That is intensity of scattered light. For intensity of scattered light at 400, intensity of scattered light at 800 is proportional to omega. This will be 2 power 4. You understand? The frequency is 2 times greater than this one. This is 400, 800. So the frequency of this one is 2 times less. Wavelength is 2 times more, frequency is 2 times less. So intensity of scattered at 400 divided by this will be 2 power 4, so it will be very high. 16 times. No, it will be 2 times 2 times 4, 80, 16 times. Next step. Next step is this one. No, this is 1 minute. 1 minute. This is square. Let us go to the next step. Suppose D is comparable to lambda. For example, lambda is, let us say, 400 nanometer. This means, look at this one, 0.4 micrometer. Or this means, look at this one, 4 into 10 power 0.4 into 10 power minus 6 meter. Or look at this one, 0.4 into 10 power minus 3 meter. So 3 millimeter. Now what is this? This is the size of a bacteria. Or this is the size of a bacteria. That means if you allow the light on a bacteria or a tiny particle of this one, wavelength under this condition, this kind of scattering is called Rayleigh scattering. And here it is in Rayleigh scattering, I scatter of light by I scattering for 400 over 800. This is proportional to lambda omega power 4. This is the property of Rayleigh scattering. This is the one which explains why sky is blue. 2. Why Jeddah sun is red. Why Riyadh sun is white. I leave these 3 questions for you. You find out the answer. First thing, why sky is blue? Why Jeddah sun is red? Why Riyadh the sun is white? Okay. This will explain why sky is, the sea water also is blue. Why water is blue? You must have gone over sea, right? If you look at the sea from the top, the sea is always blue. Why?
Because they relay scattering.
Yes. What is it? Why?
Because the size of the particle is comparable to the wavelength of the sun.
So why it should be blue? Why not red?
The ultraviolet, something like this.
It is related to think about it. Okay. Now, first thing, when I tell you the funny thing, many people say the sky is blue. So when I see the reflection. Am I right?
For the sea.
See, I put this. Go to the swimming pool. Next time, go to the swimming pool. Okay? Look at the water. There is no sky, right?
Yes.
Still, it is blue. Understand? So it is not the reflection of the sky. It is some kind of property. There is no reflection in water also. It's always a scattering. So it is solely due to the scattering, which is again a Rayleigh scattering. You find the answer. I will come back to this one. Right. Next step. Now next up, Raman scattering is again a molecular scattering. Molecular scattering. This means T is comparable to lambda. But scattered light has lambda of scatter is greater than lambda of incident. Not only that, lambda of scattered can be less than lambda of incident. Then you see the next thing.
So which the wavelength change.
Yes, wavelength changes. Not only that, look at this one. Lambda of scattered is equal to lambda of incident, since it's greater, right? Yes. Plus m lambda of m. I shall explain what it is. plus or minus. That means this is the incident light, this is the scatter. The scattered light has a wavelength with the discrete steps. What I mean is, look at this one. I says just send the light here. This is lambda incident light. Sorry, this is the lambda of incident light. Then I get another light which is lambda of scattered light. Like this, there is a gap. Since I put n, it can be 1, 0, 1, 2, 3. There is an integral step. It is like I go up the stairs, then look at it. I have to put here or here. I cannot put anywhere. I will fall down. Understand? So it goes in integral step. This Raman proved. How you prove? Just look at this one. Very simple. You take long tube, put some benzene. In fact, he started with alcohol. Pure alcohol. Send light. He sent the light to mercury. This, in fact, this is 365 nanometer. Send the light, look at it, focus it. Then put a mirror, allow the light go back. Allow the light few times. Then look at this one. The alcohol molecule interact with the light of 365 nanometer. Then look at it, collect the light here using lens. Another lens. Then you focus it here. If you put a grating, you get the light, look at it, 365 due to the incident light, and he got another light at, let me say, 385. He got another light at 405. So, on the spectrum, he got like this, more like this. Then he explained that this happens in this way. With the explanation he gave is something. The alcohol molecule is a molecule having the energy level, this one. This is the another energy level. Let us say this is S0, this is S1. These are electronic energy level of alcohol molecule. I send a light like this. Then look at it. The molecule takes the light, does not absorb, it goes. And then look at this, it comes down. Now, if you say this is the energy correspond to 365 nanometer, then after this molecule come and stop here, right? Stop here. So this, he said, this is due to 375. Suppose it stop here, this will be 385. That shows that the molecular energy levels are quantized. Look at this one. We start with the mercury lamp. We start with the mercury lamp, which costs today $100. Okay? This tube is an ordinary glass tube. This costs another $100, $200, right? You put mirror, one mirror, two mirror, three, you put any number of mirror, another $100. Total $400, let us say, right? The prism $100, $500. This will be expensive, $200, $900. Here you have a photographic plate. The photographic right? Another $100. That means all put together is about $2,000, right? The whole instrument. By doing this experiment with the $2,000 expensive, he got a Nobel Prize. He was the first non-white person to get the Nobel Prize. You could be surprised. I don't know whether you appreciate the point. See, Nobel Prize was started in 1900. And up to 1932 or 30 years, Nobel Prize was given to British scientists, Italian scientists, French scientists, German scientists, etc., etc., American scientists, not for anybody, India, China, Turkey, nobody. You know the whole of Asia? Nobody got Nobel Prize. Prof.V.Masilamani, he was the first one Asian to get the Nobel Prize.
From where?
From India.
From India.
Oh, no.
He comes from our state. He talks our language.
He serves the world.
Huh?
He serves the world in this invention.
You see the point. This is so simple, but what he showed is, he was the first one to show that molecular energy levels are quantized. This is the first and final proof. Next point is this one. You see, the next step will be surprising for you. If I can get the laser instead of mercury lamp, look at this one. Instead of mercury lamp, I remove this. I put my neodymium laser. I put a neodymium laser. Then look at this one. I choose the same thing. I don't change anything. Then look at it. I will have a laser at 532. I will have laser at 542. I will have laser at 552. Like that, right? So I can have many lasers. I don't need a crystal to tune around.
This is very good.
Try to see the simplicity of this one. You remember I told you we need a good quality crystal, right?
Yes.
Which is very expensive. And the crystal is a solid. When you focus it, I will show you the damaged crystal.
Yes,
there.
we see.
You have seen that
Yes,
one?
yes.
By mistake somebody focused it, that crystal is damaged, and that is the end of that, right? Now, with Raman instrument, I have the laser. I can take alcohol. If the alcohol is bad, throw it. I can take another alcohol which will cost only 5 riyal. Understand?
Yes.
I need to put in a glass tube which will be another 5 riyal. Totally, for me, a crystal which costs $1,000, for me it is only 100 riyal. I can throw it. Still, I can get, not only that, I can get a laser here, here. I can play around. I can get a variety of laser. Now look at it. This whole thing was, just look at this history. This was 1930. He got the Nobel Prize. In fact, yesterday was the day when he discovered. This is called February 28, 1928. That's the time when he discovered this one. In India, that is called Science Day. We celebrate. And he deserves to be celebrated because he was the first Asian to win the Nobel Prize. That's not the point. That discovery is very useful now. You see that? There are so many discoveries which people have forgotten.
Finished.
Now, this is very important now. Now, come back. So, if I use a neodymium laser, I can get a laser here. Next step, you will be surprised. Look, somewhere I said, this is this is lambda of incident light. So I can get lambda of incident light plus or minus lambda of molecule, okay? I said plus or minus, right?
Plus or minus some.
N, number,
Yes.
integer, 1, 2, 3.
Mm.
So this is plus 1, plus 2, plus 3. Next, you see the funny thing. Why should I see my mathematics show it is plus or minus?
Yes.
So if it is minus, I can have laser here also. That means
Is it symmetry?
symmetry. So I can have laser, look at it. I 532, 542, 552. I can have laser at 522, 510, 12.
But how many wavelengths we can get? How many one?
Usually I can get 2 or 3. Right. This is 2 or 3 if the laser power is weak. If the laser power is very strong, and if this particular material is really good, okay, I can get up to here. I have produced in this laboratory, I think this laboratory, with the CO2 laser, this, where is here? This I have produced 19
different wavelengths.
19 wavelengths. That was a project of one other student. Later I can give you.
And they use for this is the 19 one. We can use it.
Yes, you use. You saw the tube there?
Yeah.
That's a tube we used. I can show you. Just come here. I think we used this laser. Maybe this laser. I'm not sure. I think this laser. I think we use this laser. Okay. Next step. I said I have used 532, right? I used 532. Instead of 532, suppose I use the third harmonic of neodymium laser, 355. What will I get? I will have, look at it. 355, 365, 385. So I will have another 5 layers at this side, another 5 layers at this side. That means it's like if you go to Tamimi market, you have variety of milk. Full fat milk, half fat milk, no fat milk. I have a lactose free milk. I have 10 variety of milk. I can choose anything you want. Same way I can go to laser lab, put a Raman medium, I can get the laser you want. You order, wait for some time, like asking for a pizza with more chicken, I can get it. That's all. Let us go to the theory of this. First thing you should know what is polarization. What is this one? Look at this one. Yes. Let us go back to the simple steps. Imagine this is the hydrogen atom, this is the nucleus, this is the charge cloud. The charge cloud is like this. For an atom like this, when light is coming here, this is an electromagnetic wave. So the E vector will pull this one. So this will go like this. You will have delta plus and delta minus. This is the nucleus. Now this is called dipole. Dipole has mu equal to E dot R. This is called the dipole moment. And this is called the induced dipole moment. Because this is exist only when light is there. Not when light is absent, nothing. Next, let us consider water molecule. The molecular structure of water is this. You see the next problem. This is oxygen. Oxygen is electronegative, so you will have more negative charge and more positive charge. Positive charge. It is some, see, even though this is a this is a covalent bond, the more charge will be there on the oxygen because it's electronegative. It is something like I earn money, but my wife sends more money than me. Maybe you will see this one, maybe he's scared now. It is like this. You have more negative charge. Since here is more negative charge, this will be delta positive. Perhaps you understand. Suppose I go to shopping with me and my wife. I want to have one big suit, okay? That is my plan when I sit in the car. My wife wants to take a lot of dress. Then what happens? Finally, when we do the shopping, I come only with only one kerchief. Because money has been spent by her, you see? Yes. Same story here. You have more negative charge, so you have becomes positive. This is called permanent dipole moment. This is called permanent dipole moment. This is not permanent dipole moment. This is induced dipole moment. And this is a function of, look at it, the function of electric field. Now, we will put them both together. We write down the equation. The general equation is this. Look at it. P is called mu naught plus alpha E. Mu naught is the permanent dipole moment. I can say this is 0 for hydrogen molecule, but it is not 0 for H2. Understand? Hydrogen molecule is a homonuclear molecule. Water is not. And this is called polarizability or induced dipole moment. Next step, this alpha is a tensor of rank 2. So you must put it as alpha ij. This is true even when you consider a polarized light. When you consider unpolarized light, this will be still crazy. What I am trying to say, look at this one. I sent a light like this, which is, look, I sent a light like this, this is unpolarized. Put a polarizer. This is polarized light. Here is a water molecule. The water molecule, look at it. The water molecule will undergo changes in the electron cloud. The changes in the electron cloud will not take place only here or here, because it is a sphere, right? The sphere will be tilted like an ellipse. Since it is an ellipse, you have to represent in many vectors. We put in terms of a simplest tensor. Tensor of rank 2, because we assume it have distortion in x and y. In reality, it has many more. This is the simplest under this condition. I can write okay, then mu can be expressed as mu naught undistorted plus sigma delta mu by delta q n qn plus other term, that is we express in terms of Taylor series. And then this we express like this. This we express as alpha ij q. I shall explain what is q. Q represents the coordinate. Q represents the coordinate, or in fact is called a normal coordinate. Normal coordinate. Call Amjad, because I must go in another half. Call Amjad, give it a break.
It is recording.
Stop it, stop it.